Okay guys, I'm having some issues with sound this morning. I hope that it's working. We're going to start with Chapter 10, Section 6, Circles and Arcs. From here we're going to move to 10.7, and then from 10.7 we're going to move into Chapter 12, which is purely circles. Alright, so circles and arcs. The first thing that we need to talk about is what exactly is a circle. And it's a set of all points equidistant from a given point called the center. So if right here M was my center, all of these points that I've connected to form a circle around M, those would make up the circle. They're equidistant, right? And you would call it circle M. It's named by its center point. And you put this little symbol, a circle with a dot in the middle of it, to let people know that you're talking about a circle. All right, the diameter is a segment who crosses through the center of a circle and has both endpoints on the circle. So it would start on one side, cross through the center, and go to the other side. That would be the diameter. And then we move down here to the central angle. A central angle is an angle whose vertex is the center of a circle. So right here, here's angle P. All right, or here's circle P right there with the center. So you would name that angle BPA or angle APB. Just like an angle, that middle letter has to be where the vertex is. So angle BPA is a central angle of angle P, of circle P. Goodness. Okay, and then we're going to talk about an arc. It's a part of a circle. So if I were to go from B to A with my finger right here, this would be an arc. All right, just think it's part of a circle. From B to A, it makes a little arc. Then you have a semicircle whose arc is half a circle. That means if I went from B all the way around to this other side where I don't have a point labeled, that would be a semicircle. I could also go this way around too, B all the way around to this side. And then we have a minor arc, which is smaller than a semicircle. So BA would be a minor arc, smaller than a semicircle. And a major arc, which is larger than a semicircle. So if I went from BA and all the way over here to a point that maybe I labeled, that would be a major arc. It's bigger than the semicircle, bigger than the half circle. So let's look at these in a little bit more detail. Okay. Hopefully you can read this and make sense of it. So right here, from R to I to S, I kind of highlight it in a little green pen. That would be a semicircle, and you use 3 letters to name a semicircle, the endpoints and one point in between. So I would do R, I, S, the 2 endpoints and the middle, the point in between them. And make sure that you put an arc over the top of it, so we know we're talking about circles. RM, from R to M, which I highlighted in purple, is a minor arc. You only need 2 letters to name it, and those 2 letters are its end points. So R to M, a little arc over the top in the 2 letters. A major arc, again, goes back to 3 letters. So a major arc, I'm going to start at M, I'm going to go all the way around to I, then all the way around to S. M-I-S. It's a major arc. It's greater than a semicircle. You use 3 letters to name it, the endpoints and one of the letters in between. So I could have also named this M-R-S, but I chose to use I. No reason, just you need to make sure that you use the 2 endpoints and one of these letters in between for a major arc. Okay, let's talk about arc measure. The measure of a minor arc is equal to the measure of its corresponding central angle. So if I look at this circle here and I see that this central angle is 50 degrees, then I would know that this arc, RT, is also 50 degrees. So arc measures, they correspond to whatever the central angle is. If the central angle is 50, then the arc measure will be 50. If the central angle is 75, then the arc measure will be 75. In order to find the measure of an arc, you're going to do 360 minus the related minor arc. So for example, or for this major arc, say I wanted to find TQR. I would do 360 because that's the total amount of degrees in a circle, and I would subtract 50, the measure of arc RT. Well, 360 minus 50 would give me 310. So I know that this major arc, TQR, is 310 degrees. The measure of a semicircle is always, always, always just going to be 180 degrees. Always. Semicircle. Just think it's half a circle. 180 degrees. Then we're going to talk about adjacent arcs. Adjacent arcs, much like adjacent angles, but this time they're arcs. They are arcs of the same circle that have exactly one point in common. All right? You add the measure of adjacent arcs just like you add the measure of adjacent angles if you're trying to find the measure of the whole angle. So, what is the measure of each arc in circle O? Well, here is circle O. And the first thing we want to do is we want to find BC, arc BC. Well, I know that the measure of angle BOC is 32 degrees, right? 32 degrees. So I know that the measure of arc BC is also 32 degrees. And then I want to find BD. Well, I know now that BC, the arc, is 32. And I know the arc of CD is 58. I would simply add those two together, 32 plus 58, and get 90. These would be adjacent arcs, and I've added them together to find this total arc measure, all of BD. All right, they are touching, so they are adjacent arcs. The next thing I want to look at is ABC, from A to B to C. Well, that's a semicircle, so I know straight away that's just 180 degrees. All right, straight up 180 degrees. And lastly, I want to find the measure of arc AB. Well, arc AB makes up part of the semicircle, which is 180 degrees, right? And BC makes up the rest of it. So I'm going to do 180 minus 32, and that's going to give me 148 degrees. So I took the semicircle measure, 180, subtracted 32 because I knew that arc measure, and I got 148 degrees for the measure of arc AB. Here's something that you guys should feel a little bit comfortable with, at least something that you've seen before, whether you remember it or not. Circumference of a circle. There's two formulas for that. It's pi times the diameter, or 2 pi r. Not pi r squared, but 2 pi r. D is the diameter, r is the radius. It is the distance around a circle. Circumference gives you the distance around a circle. All right, and then something else I want you guys to keep in mind are concentric circles. Circles with the same center who lie on the same plane. So, right here, these two circles, they both have the same center, which I'm going to say is H, even though there's an H and a K here. That K is supposed to represent the radii. Circle H and the greater circle H would be concentric circles, circles that lie on the same plane and have the same center. Okay guys, kind of a longer video, lots of vocab, but best get to memorizing it, and I will see you tomorrow. Bye.